Good morning, Dr. Noorani. Today, our group would like to present about personal care and cosmetic production. The contents of this presentation includes an introduction which would be presented by me, Safiya Shariff, greener ingredients which would be presented by Farahani, greener process which would be presented by Khairul Farhan, greener products which would be presented by Madihah, benefits and closure which would be presented by Alia Najwa, and references. Green chemistry is the utilization of a set of principles that reduces or eliminates the use or generation of hazardous substances in the design, manufacture, and application of chemical products. Green chemistry in personal care and cosmetic production. These are products using environmentally friendly ingredients, production process, and packaging materials. For example, using organic ingredients, manufacturing products with renewable energy sources, and using recycled packaging. We would further divide this into three main parts, which are greener ingredients, greener process, and greener products. There are 12 principles in green chemistry. In greener ingredients, we would be looking at Principle 3, less hazardous chemical synthesis, Principle 5, safer solvents and auxiliaries, Principle 6, design for energy efficiency, Principle 7, use of renewable feedstock, Principle 8, reduce derivatives, and Principle 12, inherently safer chemistry for accident prevention. In greener process, we would be looking at Principle 1, waste prevention, Principle 2, atom economy, Principle 3, less hazardous chemical synthesis, Principle 9, Catalysis, and Principle 11, real-time analysis for pollution prevention. And lastly, in greener products, we would be looking at Principle 1, waste prevention, Principle 2, atom economy, Principle 4, designing safer chemicals, Principle 5, safer solvents and auxiliaries, Principle 7, use of renewable feedstock, Principle 9, catalysis, and Principle 10, design for degradation. The future of green chemistry in personal care and cosmetic production. The global organic personal care market size was estimated to be at $13.3 billion in 2018, with an estimated CAGR of 9.4% between the years 2019 and 2025. Whereas the global organic cosmetics market size was estimated to be at $34.12 billion in 2018, with an estimated CAGR of 5.01% between the years 2019 and 2025. CAGR is the compound annual growth rate. There are a few reasons for the growth of the organic personal care and cosmetic market. First is the rise in research and development to introduce improved ingredients into various products. Next, supportive government policies and regulations supporting the manufacture of organic products. Furthermore, there is an increase in awareness regarding various benefits of organic products as compared to their synthetic counterparts. Moreover, there is an increase in availability and accessibility of these products across various distribution channels, and also a rise of online market where consumers can access a wide range of organic products worldwide. In addition, technological innovations which are aimed at the development of cost-effective organic products. And lastly, these products reflect the growing aspirations of consumers for better hygiene, health, and beauty in these modern times. There are a few adverse effects of personal care and cosmetics production that does not practice green chemistry. First, toxic chemicals in the products will eventually end up in the soil or ocean, which causes destruction to natural habitats and wildlife. Second, The packaging of the products can take hundreds of years to break down in the landfill. Third, marine animals may ingest microbeads, wet wipes, and plastic packaging, which would block their digestive tract and cause them to die.
I am Noor Farahani. Now I will explain about greener ingredient. The term of greener ingredient in cosmetic production indicates that the cosmetic products were made from natural ingredients formula that is not harmful to the users. I will discuss about the example of cosmetic ingredients that does not apply the principle of green chemistry. The first ingredients are butylated compounds. Butylated compounds, which is butylated hydroxytoluene and beta-hydroxy acid, have a function as an antioxidant. It is mainly used in the production of moisturizing creams, lipstick products, sunscreen, deodorants, and many more. However, it can cause disturbance in the normal function of endocrine system. The second ingredient is dibutylphthalate, or known as DBP. DBP is used to increase the durability of polish. Speaking of polish, it is one of the main ingredients that is found in the nail product, which is nail polish. It also can be found in the hairsprays. DBP is toxic to humans, especially towards the human reproductive system, which is related to fertility issue. Greener ingredients in cosmetic productions. The first ingredient is sodium hydrosulfide. In this case, I will talk about thioglycolic acid production. Thioglycolic acid, or TGA, is used in hair weaving formulation. Initially, TGA is produced from hydrogen sulfide. The downside of using hydrogen sulfide is it is hazardous to human and to environment. Hydrogen sulfide can cause air and water pollution. To make the production less hazardous, hydrogen sulfide is replaced with sodium hydrosulfide. This replacement follows the third principle, which is less hazardous chemical synthesis. Next, I will talk about alkyl polyglycoside surfactants, or shortly known as APG surfactants. It is used for the production of personal care and detergents. Rather than using petrochemical-based technologies, APG surfactants are safer and biodegradable since it was produced from renewable resources, which is glucose and fatty alcohol. These ingredients follow the principle 7 and 12, which is the use of renewable feedstock and inherently safer chemistry for accident prevention. The third one is by replacing petrochemical with polysaccharide. In this process, petrochemical is replaced with leaven, a polymer that is derived from fructose. Leaven has many advantages. One of it is it can possess an acid-stable properties. It also has low intrinsic viscosity, which require less energy to handle. Leaven also cost-effective, thermostable, and safer to use, rather than using petrochemical that is flammable and can cause skin or eye irritation. This process follows the Principle 6, which is designed for energy efficiency, and Principle 12, which is inherently safer chemistry for accident prevention. Lastly, is the development of solventless process in making tackifier and adhesive. The development in making tackifier is to produce waterproof, long-lasting, and make the cosmetic product comfortable to wear. Tackifier dispersion will manufacture pressure-sensitive adhesive that initially involving organic solvent to dissolve the resin at a high temperature. Solvent emission occurred while evaporating the excess solvent, which contribute to greenhouse emission. In the solventless process, the resin will be pulverized into a fine particle. This particle can directly form the dispersion in water in just a few minutes. Therefore, it does not require heat process and the solvents. Because of that, less energy will be used. At the end, it also can reduce the greenhouse emission. This process follows the principle 5, 6, and 8, which is safer solvent and auxiliaries designed for energy efficiency and reduced derivative.
Assalamualaikum and hi everyone. My name is Mohd Farhan 172042886. So I'll be presenting for the greener process. Greener process can be used in biotechnological routes to tailor the polymeric product. Polymer could be made from the renewable resources that involve all aqueous green chemical by using the microbial polymerization, except for one problem: the ability to control the product structural variables that ultimately determine the functional properties. However, based on the research Richard in the Department of Chemistry, University of Massachusetts at the Laurel, and David, Department of the Chemical Engineering, Tufts Universities, address this problem by disclosing a family of technologies that demonstrate the unprecedented level of the control for non-ribosomal mediated microbial polymerization. So the principle that relates to this slide is waste prevention. Based on the three technologies, the first technology is a process of preparing lipoheteropolysaccharides from a renewable sources and develop innovative methods to control the product fatty acid structure and the degree of the substitution. This led to diverse family of the new biodegradable bioimmosphere that have a wide applicability for biocosmetic and other fields. A second technology area has been used on polyethyl glycols to regulate the microbial polyester molecule weight, lipid unit composition, and alter lipid unit sequence distribution. Furthermore, this strategy can be used to form microbial polyester polyethylglycol diblocks copolymers. It is now possible to consider the in vivo preparation of synthetic natural diblocks. This technology creates a number of opportunities for the preparation of completely biointegrable interfacial agents for the blends. The termination of chains with the reactive end groups for the coupling pharmacological active molecule and engineering for surface molecules. And the last technology, which is develop of new fermentation routes to ionic gamma polyglutamic acid from renewable resources such as glucose. Gamma polyglutamic acid is a cosmetic thickener. This route has potential to replace a million of pounds of ionic polymers such as poly, uh, polyacrylic acid, which is non-biodegradable and persistent in nature. So principles that relate to this is atom economy and less hazardous chemical synthesis. However, they need a mediums of the enzymes and aldose in order to create the natural green product. So the solution is to formulate the enzyme in a cross-linked crystallized form, a CLC, that enable the enzyme to be used under the harsh chemical, physical, and mechanical conditions that categorize most practical industrial process. More than 20 enzymes has been formulated as CLC, and Altos Biologics has demonstrated their utility on the pilot scale in consumer products such as detergent and cosmetic among the range of application. Second is reducing the copper catalyst content in ATRP, which is atom transfer radical polymerization. So it is used to control transition metal mediated process to polymerize appropriate monomer by radical mechanism. It was discovered in 1995 in the laboratories of Christoph, Department of Chemistry, Carnegie Mellon University, many industrial research programs are actively using this process to prepare polymer for a broad spectrum of application, including cosmetic. So, how this ATRP is used? Actually, the group of Christoph has put a lot of effort to develop the more active catalyst system targeted at reducing the level of metal in ATRP system by using the hybrid catalyst in a process called activator generator by electron transfer agent and activator regenerated by electron transfer agent. This new process will eliminate all hazardous substance from the product made by ATRP and from the waste stream of the industrial production. And this principle can be related is use catalyst and analyze real time to prevent pollution.
I'm Nur Madihah and I will continue with greener products. Greener products are designed to reduce energy consumption, use less natural resources, raise the recycled material, and reduce or eliminate toxic substances. The first product is lowering volatile organic compounds (VOCs) in hairsprays. Development of a water dispersible sulfur polyester that allow hairspray to be formulated with 55% ethanol. It produced hairspray with 45% VOC, which was significantly less than the contemporary industry standard of 80% VOC. The current switching resulted in total reduction of VOC emission around 55 million pounds per year. This product applies Principle 4 in green chemistry, which is designing safer chemicals. Okay, and the second product is nail polish bottles with greener labels. Compared to the traditional heat cure glass decorating process, technology nowadays uses the organic-based UV curable inks. This ink had no VOC and no toxic heavy metals. This technology directly silk screens radiation curable inks onto the glass, then cures the ink almost instantly by exposure to UV light, which then resulted in a crisp, clean label that is environmentally safe with a unit cost that is about half of the ink cure with traditional labeling. This product applies Principle 1, which is waste prevention by planning ahead to minimize the waste. The third product is biocatalytic production of a soy-based sunscreen active. This sunscreen was manufactured to meet all the criteria for a green chemical and green production process. The chemical is made by biocatalysis of renewable feedstocks, which are ethanol, ferulic acid, and soybean oil. The biocatalyst used is Candida antarctica lipase B. This enzyme efficiently transesterifies the ethyl ester of ferulic acid onto the glycerol backbone of vegetable oil, which produces a mixture of ferulylated monoacylglycerol and diacylglycerol. The desired ferulylated acylglycerol are separated from unreacted ethyl ferulic and ferulic acid by molecular distillation or liquid carbon dioxide extraction. Recovered ethyl ferulate and ferulic acid are returned to the process, which resulting in very high atom efficiency, which apply Principle 2 in green chemistry. This production also apply Principle 7, which is use of renewable stock, and Principle 9 by using catalytic instead of stoichiometric reagent. Last product is alternative to toxic microbicidal chemicals. As an alternative to toxic and oxidizing chemicals for the personal care and health industry, a broad-spectrum microbicidal products was developed. It used ingredients listed by the Food and Drug Administration and APA as biodegradable, generally recognized as safe, GRAS, food additives, and non-polluting. This applied Principle 5 in green chemistry, which is use of the safer solvents and auxiliaries. The products also use surfactants at low pH. Raising the pH diminish the microbicidal properties, allowing safe environmental disposal and biodegradation of the product after use. Principle 10, which is designed for degradation, is applied here. This product selectively kills microorganisms on body parts, including mucosal and skin surface, without covalent chemical reaction.
My name is Nur Alia Najwa, and now I will talk about the three major benefits of using green cosmetics, which include environmental responsibility, increased effectiveness, and long-term effect. The first benefit is environmental responsibility. Modern consumers have a growing global consciousness and they care about the social and environmental responsibility. Every week, a new story about a toxic greenhouse emission or vast plastic floats in the ocean emerge. Many of the petrochemicals used in conventional cosmetics are harmful toxins that damage both the atmosphere and our body. Therefore, one of the main benefits of green products is their kinder environmental impact. Green products are made from organic and biodegradable materials that are designed to use least non-renewable resources and non-toxic chemicals to produce energy. The use of green cosmetic will reduce the use of hazardous substances in the design and manufacture with the application of green chemistry. The ban on microbeads is a recent example of pollution and consumer demand. Some shower scrubs and exfoliating materials contain microbeads, which are tiny bits of plastic. However, they do not dissolve, and in 2015, a study reported that over 8 trillion microbeads were being washed into our waterways every day. Next, the use of green cosmetics show a better effectiveness than using conventional cosmetics. Eco-friendly products benefit both physical and emotional health since they are manufactured from materials that are free of toxic chemicals and components. Natural and oleochemical ingredients are less likely to cause skin irritation or allergic reactions. Without synthetic, toxic chemicals or artificial colors, sustainable products rely on healing properties found naturally in plants and animals. The ingredients humans have been using for centuries. Glycerin is a natural derivative of palm oil that is clear and non-toxic liquid. It is used in making soaps, pharmaceuticals, and cosmetics products. Since it is a humectant, glycerin can retain water, making it an excellent moisturizer. Glycerin enhances the body's hygroscopic characteristic, encouraging the skin to absorb and hold on to water. It is an effective anti-aging ingredient, and due to its antimicrobial properties, it can also serve as an acne treatment. Lastly, long-term effect of using green cosmetics is cost-effective products for consumers. Green products last longer than conventional products. These products consume less energy and other resources during the manufacturing process, thus reducing the bills of the users. Second, advantages of going green to the brands is opening access to the new markets. Developing green products open the doors to an all-new market of green consumers who buy only green products and even pay more for the same. Lastly, it may improve consumers' health. By choosing sustainable cosmetics, consumers opt for long-term well-being and beauty over the stress and instability of harmful synthetic products. In conclusion, green cosmetic production and personal care applies all of the 12 principles of green chemistry. Nowadays, consumers are increasingly demanding sustainable products that are not toxic to themselves or to the environment. The natural market is expanding, and using raw, natural products would establish the brand as a safe investment, both environmentally and financially. Manufacturers who switch to organic and green cosmetics manufacturing have a bright future ahead of them. These are the resources cited by our group members. That's all from our group. Thank you.